There are more than 100 radio telescopes on Earth, yet we barely get any radio astronomy data. You might say, but radio telescopes gave us crucial information, like the cosmic microwave background. True, but it's not enough. Earth's atmosphere blocks most radio waves from reaching us, bouncing them back into space. This means we're missing out on important signals, which limits our understanding of the universe's origins. What's the solution? We need a radio telescope in space. But how do we make that happen? And why is it more essential than any other space telescope? Let's explore that in today's video. Now, look at this wavelength chart. The shorter the wavelength, the more energy it carries. But as the wavelength increases, the energy decreases. When cosmic events happen, all the waves from those events come to us in their original form, assuming there's no interference. But Earth's protective ozone layer, while crucial for human life, is a nightmare for astronomers. It blocks ultraviolet and short wavelengths from reaching us and reflects longer radio waves. As a result, radio astronomers only get a limited range of wavelengths, called the radio window, and even this window keeps changing based on atmospheric conditions. So, what's the problem? Why not just rely on Earth-based radio telescopes? Well, after the Big Bang, about 400,000 years later, the universe entered a dark age that lasted for 600 million years. During this time, there were no stars or galaxies, just a massive cloud of hydrogen. This period holds some of the oldest radio waves, but those waves are so weak and stretched by now that Earth's atmosphere blocks them. No matter how advanced our Earth-based telescopes are, they simply can't capture these ancient signals. So why not build a space radio telescope like we have for other wavelengths? Well, it's not that simple. Radio telescopes need a huge aperture. The bigger the aperture, the older the signals they can capture. To study radio waves from the Big Bang, a telescope would need a dish at least 1 kilometer wide. Building something that massive in space is nearly impossible with today's technology. But what if we build the radio telescope on another cosmic body without an atmosphere? That brings us to two options: Mars and the Moon. Mars, however, has issues like massive dust storms that could cover the telescope. So, the Moon becomes the perfect candidate. Scientists have proposed building a radio telescope in a lunar crater on the far side of the Moon, where it would be shielded from Earth's interference. The Moon's stable environment makes it ideal for this project. This lunar radio telescope would be made from a wire mesh, deployed by rovers around the crater. As these rovers move away from each other, the mesh would unfold, creating the telescope. NASA has already invested $500,000 into this project, and while there haven't been major public updates, development is underway. This telescope, called the Lunar Crater Radio Telescope LCRT, would be located on the Moon's far side, away from Earth's noise. It could detect radio waves longer than 10 meters, waves so old that they might date back to the Big Bang itself. And because it's on the far side of the Moon, it won't pick up any interference from Earth or even the Sun during the lunar night. If completed, this telescope will be the largest radio telescope in the solar system, potentially allowing us to hear signals from the dawn of the universe. If you enjoyed this video and learned something new, please like, share, and subscribe. Don't forget to turn on the notification bell so you never miss an episode. See you next time.